Hello, everyone. Today we are talking about LAMs. We have been talking a lot about LLMs, which are good at understanding and generating text or images or videos whatsoever. Today we are going to talk about LAMs. So, with LAMs, such levels of autonomy and comprehension, turn the Gen AI into an active assistant which can perform tasks like the subsequent actions like booking rooms or making complex decisions based on the data analysis of past or present behaviors of the user. So to achieve this level of informed decision making, lambs should learn from very massive data sets that contains action information of the user, like what he has been doing, in which scenario, what action he used to perform. Such kind of analysis is really important, and it uses this data for the strategic planning and the real time decision making in terms of actions. So researchers at Microsoft have created what they call a large action model, an AI model that can operate Windows programs on its own. So the traditional AI models mainly process and generate text or image or video, but LAMs take things a bit further. So they are capable of turning user requests into real actions. These actions can include like operating software to even controlling robots. So of course this concept is not new. We have been seeing this from a long time. LAM is just the first model that has been specifically trained to work with Microsoft Office products. So LAMs as a concept gained popularity in I think you have heard about this product called the Rabbit's AI device. It was released in the first half of 2024 last year, and it was launched with an AI that could interact with the mobile applications without the need of the user. Um, so the R1 was marketed to be a very good product at understanding your spoken requests and questions. It is built on the LAM, large action model. This means you can interact with it in a conversational way, just like you would do with a person, right? And this R1 can perform a wide range of tasks on your behalf, like, sending messages, making calls, setting reminders, or playing music, ordering food or rides, controlling smart home devices, whatsoever, you name it, you will be able to ask to do it. So it's designed to be a universal controller for your apps, the R1 device. So I'm just telling you an example about how LAM is used and what products it could bring to the market. So this means that it can learn how to use your existing apps and perform actions within them, even if those apps don't have their own voice assistants. So the R1 has a rotating camera, this device, which allows to see and interact with the world around you. This enables features like, object identification, visual search, like the understanding of the scene um, around you, and it could also access the video. So why this R1 was a failure is another story, of course, because of the marketing hype that has been created, whereas the reality check proves otherwise. So the device struggled with the basic commands itself and often failed to integrate with apps as advertised. And there was also limited app support while R1 aimed to be a universal app controller. Its actual app integration was not very great, or it was actually limited and often very unreliable. It was a very promising product which was built on LAM, whatsoever, be it a failure or was it successful. But there have been a lot of examples which have been coming into the market in this year, like the Meta glasses. So it also uses LAM to perform actions, like you can ask Meta to read the messages that you got on WhatsApp, or you could ask it to play music on the integrated application. So there are some applications which are compatible with the AI element of the Meta glasses, where you could give commands and the actions on that app could happen. So how LAM models work is LAM models can understand inputs such as the text that you provide, or the voice, or images. So they can convert these requests into detailed step by step plans, so they are also able to adjust their approach in real time. In simple words, LAMs are AIs that are, designed not just to understand, but to act well as well. So based on the research paper, large action models from inception to implementation, these models have been designed to interact with both digital and physical environments as well. So think of it like, instead of asking an AI how to create a PowerPoint presentation, one could ask an AI to open the app, create slides, and format them. You give them specifications like format like this, and they could do the same according to your preferences. So at its core, LAMs essentially combine understanding intent, what you want to do, meaning they interpret the user commands accurately, and then action generation, which is the ability to plan these steps, the actionable steps, and dynamic adaptation as they're able to adjust based on the feedback from the environment. When compared to LLMs, and the creation of LAM is far more complex. It involves like different stages. So data is the foundation of any AI, of course, and LAMs require two types of data, like the task planning data, which are like the high level steps for tasks such as opening a Word document and highlighting text, etc. So the second type is the task action data, so which is specifically like the doable steps. When it comes to training, these models undergo something known as supervised fine tuning and reinforcement learning and imitation learning. So before they are deployed, these models are tested in controlled environments. They are also integrated into the agent systems to interact with other environments. Eventually, these models are tested in live scenarios to gauge its capabilities and adaptability and performance. So, as per Microsoft, it's not currently available for all users as part of the Microsoft's proprietary Windows software. LAM is a new AI model developed by Microsoft that can autonomously operate Windows programs, but it is still in research and development phase. While the field of LAM is still emerging, there are few notable models and frameworks available in this space already. So the XLAM, it's developed by Salesforce AI Research. This series of models is basically designed for AI agent tasks. They range from compact models like 1 billion parameters suitable for on-device deployment to larger ones like 8 times like 22 billion parameters for more complex tasks. So XLAM models are trained on diverse data sets and optimized for tool use and general AI agent performance. And there is another model like LAWAG. This framework focuses on building AI agents that can learn from the environment and interact with the environment. Well, it's not strictly a LAM in the same lines as XLAM. It shares like the goal of enabling AI to take actions. And there is this Google's RT2, though not explicitly labeled as a LAM. This is kind of a robotics transformer. It's an RT2. It's a vision language action model that can translate visual and language instructions into robotic actions. This shows the growing capabilities of AI, to bridge the gap between how it's being perceived and how it acts. Uh, so there are some challenges in terms of development and implementation of these LAMs. Like training LAMs requires almost like very high computational power, because the data that is used for training is like huge. So these are really resource heavy models. So this can lead to high costs and environmental concerns. Also, the data quality issues are always there, as high quality data sources for training AI models become, exhausted. The other option is to use the synthetic data sets. So this can introduce new biases and, impact model accuracy. Also, there is an issue with the integration with the external tools. While connecting LAMs to external tools and systems is the important step in making a lamp successful. It's actually very complex because it is action oriented and it requires careful design and implementation. Otherwise, it might raise security risks. As lamps become more capable of this autonomous action, concerns about the extent of the decision making power and need for human oversight is largely growing. So just think of this scenario: you use a lamp to manage your social media presence, let's say, and you have scheduled posts or response to comments and even generating content. So the lamp learns your style and preferences and it can interact with your followers on your behalf. So what if lamp posts something inappropriate or offensive? What if lamp misinterprets a comment and responds, in a way that damages your reputation? Or could the lamb be used to spread misinformation or, manipulate public opinion when it is assigned to post content? So these are all risks which need to be, largely addressed before it is really widely used. So from automating workflows to helping people with disabilities, lamps are not just smarter AI, but AIs that can be more useful in everyday lives. So, as technology evolves, LAM may soon become a standard AI system for all sectors, I'm sure. So, that's all for today. Thank you. See you again. Bye.